How to graph piecewise defined functions, part one. This is where we're um, trying to graph a few piecewise defined functions with two cases. Um, so this is the first example. F of x is equal to 2, and for f of x equal to 2, the rule of function is 2 for x less than equal to 3. It's 1 over x minus 3 for x bigger than 3. And so if you're looking at it, the first one is the domain of the first case is the negative infinity and 3, including 3, that's closed on 3. And then the domain of the second one is 3 and infinity, not including 3, that's open, 3 and infinity. The entire domain is negative infinity to infinity. So to graph the function, follow these steps. Find the cutoff values for x, draw vertical dotted lines at the values in 1, process in 2 divides the plane into n strips. And so in each section of the plane, graph the appropriate piece. Find where x equal to is given in the rules of the pieces. That will tell you which side to put the full or empty circles. What do I mean by x equal to? X equal to one of the to each of the cutoffs. Okay, so let's see examples with two cases. Here's an example. And the following two examples are going to be very similar to this one. The only thing that would be different is the equal sign is different in these two. So in this example, the rule of a function is 2 when x is less than equal to 3. It's 3 minus x if x is bigger than 3. Again, if you put in, this is the interval negative infinity and 3 including 3. This one is the interval 3 and infinity, not including 3. So if you put them together, you get the entire domain. Now let's graph it. So when we're graphing it, we have to find a cutoff. Cutoff is at 3, and this is where the cutoff for the first piece is 3 and the cutoff for the second piece at 3, and therefore we have to draw a vertical line at x equal to 3 right here. And so here's the vertical line, and then graph the first piece in the appropriate section, which is this one. Graph the second piece in the appropriate section, which is the second strip. And so here's the first one, y equal to 2. And then second one is y equal to 3 minus x. So we did that and we weren't worried about the cutoff point in either of them. Now it's time to worry about the cutoff point. Cutoff point, the value of cutoff point, the y value for cutoff point is given in here because this piece of the function, this rule actually includes the domain the domain point x equal to 3. So x equal to 3 is in this piece. Figure out what y value it takes. That's 2, and 3 and 2 is going to be right over here. And then this piece of the function is not going to have an endpoint at x equal to 3 because it's not included in here. So one closed circle in here, one open circle, one filled circle, and one empty circle in here. And so that one filled, this one empty inside. And so the next one, instead of having the next example, instead of having equal sign here, we'll have equal sign in there. And so see right here. Again, the two pieces of interval, the two pieces of function have domains that union up to negative infinity to infinity. The first one, it doesn't include 3, is negative infinity and 3 open, and then 3 closed, and infinity. So this time though, when we put in the empty and full circles, the empty circle is going to be here because that the pad that ends up to be 3 doesn't include the point 3 or any 3 and anything. So that pad is coming and ending up here, and but we don't have a value for y value for x on that pad. But we do have a y value for y value for x equal to 3 on this pad, and that would be the field circle. So now, how about if we don't have any of these, right? So what do we do? Oh, first thing to notice, the first interval is negative infinity and 3 open. The second interval is 3 and infinity open. Therefore, the union of them, which doesn't include 3, is not the entire R. That's something to notice. And then what happens since I don't have any equal sign in either of the domains for x equal to 3 for the cutoff point, and it means that both paths don't end up to have a y value for x equal to 3. Therefore, there are empty circles where the paths are predicting for x equal to 3 to be. Okay, so far we always had an empty or full circles. See, we can have 2 empty circles on a vertical lines, but we cannot have 2 full circles on a vertical line because we are by the vertical line test. That's something to notice. Compare example 1, 2, 3, to see how we chose the empty or full circle. Now, here's an example that you don't see even empty circle but you see the full circle. So the rule of function is 2x minus 2 for x less than equal to 2, and it's 1 over x minus 2 for x bigger than 2. Again, the cutoff is 2. The entire negative infinity and infinity is the domain. Let's see. Put the cutoff vertical line at 2. Draw this function on the appropriate side, draw this function on the appropriate side, and then, the field circle should be on the other side, so put it in there. Do I have an empty circle? No. Why is that? Because this path actually is going toward infinity as the path is approaching x equal to 2, and therefore is not predicting anything for x equal to 2, so you don't have to worry about it. When we put the empty circle is when we have an end point for the path. This path doesn't have an endpoint because it goes to infinity. So the next part of the lesson is going to be about piecewise defined functions with three cases, or in which 3 or more would be similar. So listen to the next video on 3 cases.